So hi, good morning. Welcome again to this another series lecture about the review on the basic concepts on the basic electrical theories in preparation for your written assessment. So we are now on the third part of our review. We will be reviewing questions number 21 to 30. Okay, so again, if this is the first time that you are going to watch this discussion, so you may study along with me. But if this is the second time that you will be viewing this video, please pause before we start solving these solutions. Okay, this is for you to check if you've really understood what you've studied in the previous viewing of this lecture. Okay, so let's check this one here. So, for example, in problem number 21, so at the end of the 12-day period, your utility bill shows that you use 18 kilowatts. So you use 18 kilowatts. What is your average daily power? Take note, guys, that the average you just have to plus and then day 1, day 2, day 3, day 4, day 5, and then divided by 12. So in this particular case here, if you are going to get the average daily power given the total 18 kilowatts, you just have to do it. 18 kilowatt hour divided by 12 because you have 12 number of days. So that is equal to 18 divided by 12. So that is equal to 1.5. So 1.5 kilowatt hour a day. So given on average that you are consuming 1.5 kilowatt hour of energy uh, daily. Okay. So now let's proceed with question number 22 here. A 100 ohm resistor must carry a maximum current of 25 milliampere. Its rating should be at least, so we have to compute for the power here. Okay, so as what we have discussed in the previous examples, previous discussions, we have the power is just the product of the power times the voltage. Okay, so power times voltage. We already have a current here. Already have a current. We have a current here, but we don't have the voltage. So there are some options that we can do here. We can find the voltage. Okay, we can find the voltage using the since this is the current and then the ohms resistance, we can find the voltage there. Okay, so maybe we can do that. And then we can do the alternative options later on. Okay, so you have the voltage. Okay, given this one here, the voltage IR. So the voltage is just the product of, no, sorry. So the voltage is just the product of your current times resistance. So the voltage is just the product of your current and the resistance here. So the current is equal to 25 milliampere. So in this particular case here, that is equal to, so 25 milliampere. So you just have to move that one, 3 decimal places. So you have 1, 2, 3. This is the new decimal point. You put some zero there to convert that one to ampere. So that is equal to 0.025 ampere. And then the resistance in this particular case is 100 ohms. Okay, solving for the voltage, you have 0. Or you can do it divided by 1,000. 25 divided by 1,000 to convert that one to milliampere. Okay, so that is same 0.025. Multiply that one to 100. Okay, that I think that's not correct. So 0.025 multiplied to 1,000, 100. So that is equal to 2.5. Okay, so that is equal to 2.5 volts. Okay, so this is the voltage. So now you can compute for the power here, the minimum power. The power is equal to the current, which is equal to 0.025 ampere multiplied to the voltage 2.5 volts is equal to, so 2.5 multiplied by 0.025 equals, so that is equal to 0.0625, 0.0625 watts. Okay, 0.625 watts. So this is 0.625 watts. So that should be the answer. Let's put it here, 0.0625. So this should be the at least, okay, at least the minimum wattage for that particular resistor. Okay, so let's solve number 23 here. So if you use a 200 watts of power for 30 hours, you use, so basically, we just have to compute for the watt hour. Okay? So the kilowatt hour. So the answer should be in kilowatt hour. The normal answer should be in kilowatt hour. So we have to convert this first, the 200 watts to a kilowatt. So that is equal to 200. Okay, you just have to divide that one by 1,000. Okay, and then multiply that one to 30. Okay, or that is equal to 0.200. Okay, if you're going to divide that 200 divided by 1,000, that should be the zero point 0.2 or 0.200 kilowatt multiplied to 30. That is 30 hours. Okay, so 0.2 times 30. So that is equal to 6 kilowatt hours. So this should be your answer. So very simple as that. Okay, so let's proceed with number 24 here. So again, if this is your second time watching this video, please pause for a while and then try to answer on your own. Okay, but if this is your first time, we can proceed with our discussion. So a 12-volt battery is connected to a 300 ohm load. Okay, so a 12-volt battery. And then you have, so let's put some values here. The voltage is equal to 12 volts. Okay, and then the resistance is equal to 30 ohms. Okay, and then we have here 40 ampere hour, the charge. Okay, how long will it supply to the load? So it means to say this is very similar to the power bank that you are having now. The rating for the charge there is in terms of ampere hour, but normally we can see mAh. That is milliampere hour. Okay, that's the rating of your power bank. Sometimes you have 20 milliampere hour, 20,000 milliampere hour. So that is basically the same by 20 ampere hour. Okay, so in this particular case here, 40 ampere hour. So you have a load which is 300 ohms. So what we want to do here is we want to find the current first. Okay, we want to find the current, okay, of that load. So given here the 12 volts being supplied to that load. Okay, so what's the current being supplied to that load? And then after we compute the current being supplied to the load, we can now compute for the number of hours. Okay, the number of hours for this particular supply or for this particular battery to last. Okay, so let's solve for the current here. According to this formula here, VIR, okay, the I here, the formula of I is voltage divided by the resistance. So in this particular case here, the voltage is equal to 12 volts, and then the resistance is 300 ohms. Okay, so divide that one. The voltage is 12, then divided by the 300. Well, so that is equal to 0.4, 0.04 amperes. So it means that this particular device here is consuming 0.4 amperes. Okay, 0.4 amperes. Now, in order for us to get how many hours remaining are we going to have this battery being supplying this particular amount of current to that load, you just have to divide it one. You can take a look at the conversion. You can take a look. Very important when you will be solving this type of problems that you have to take a look at the units. Okay, so in this particular case here, the units is 40 ampere hours. If you're going to divide the 40 ampere hours with the 0.04 hours ampere, so you will have the hours because the amperes will be cancelled out. Okay, let's take a look at here. So what I'm trying to say here is we cannot multiply this one because if we're going to multiply this one, the unit will be ampere squared hour. But in this particular case here, if we're going to divide that one, 40 ampere hour divided by 0.04 ampere, we can directly see that if we're going to cancel this hours, ampere, the remaining unit will be the hours. So that's the correct way. Kasi we want to solve for the number of hours. Okay? So in this particular case here, you just have to divide the 40 divided by the 0.04. So 40 divided by the current consumption, 0.04, equals, so that is equal to 1,000. So in this particular case here, 1,000 hours. Okay? So in this particular case here, the battery can last up to 1,000 hours. Okay? So as simple as that. Number 25, let's proceed. In 20 kilowatt, there are, so in terms, the choices here will be in terms of watts. So based on our previous discussion, this is just equal to 20,000 watts. A stands 4,000. So if you're, this is 20 kilowatts, so it means that you have 20,000 watts. Okay? So if you use 6,500 watts of power for 50 hours, you have used, so we have to consult to have the kilowatt hour. So again, do not multiply directly. We have to convert that 6,500 first, 6,500 watt first to kilowatt. Okay? So that is equal to, you just have to divide that one. Based on the conversion factor, that 1 kilowatt is equal to 1,000 watt. So we just have to multiply that one with 6,500 watt, and then these watts here will be canceled out. So this is equal to 6.5 kilowatt. Okay, if you're going to solve for the kilowatt hour, you just have to multiply this one, 6.5 kilowatt, multiply that one to the hours, 50 hours. So that is equal to 6.5 times 50. That is equal to 325 kilowatt hour. So very simple. Simple as that. Okay, let's proceed with the number 27. Okay, so again, if this is the first time, is the second time that you have watched this video, pause for a while and then try to solve for this problem here. So for the first time, let's continue. How much continuous current can be drawn from a 50 ampere hour battery for 15 hours? So very simple. Just do a manipulation of the units here. So you have 50 ampere hour. So we have here the R. We have to eliminate this R here. We have to eliminate the R here because we want to solve for the current here. So to do that, we just have to divide this one by 15 R. So the R's here in the numerator will be canceled out by this numerator here. So basically, we are going to have the ampere in this particular case. So we just have to divide that one. We have 50 divided by 15. That is equal to 3. That is 3.33 amperes. So this should be the answer. Very, very simple. Okay, so 18,000 watts is the same as, so 18,000, 1,000 is K. Okay, that is K. So watts is W. So this is 18. So basically, this is 18 kilowatts. So that should be the answer. Next, so what is the equivalent of 0.008 ampere? So again, we have to convert this one to milliampere, 0.008. So you move the decimal places. You move the decimal place to the right. So you have 1, 2, 3. So this is the new position of your decimal point. So that is equal to 8 milliamperes. So this should be the answer. Or you can do the conversion factor. You have the 0.08 ampere. So the conversion factor here, multiply that one by 1,000 milliampere is equal to 1 ampere. Okay? So you have to cancel this ampere here. Ampere. So we will have the milliampere. So if you're going to use your calculator, you will come up with the same result here, the 8 milliamperes. Okay? So the last for this particular problem is what is the equivalent of 100 milliampere, 100 milliampere in ampere. So very, very simple. Again, you can do the conversion factor, or you can do the movement of your decimal point. So in this particular case, the decimal point is here. Move 3 decimal places to the left. 1, 2, 3. So it should be here. That is equal to 0.1. Oops. Should be 0.1 amperes. Okay, if you are not really good at left at right, you can do a solve using the conversion factor. Okay, so let's have a 100 milliampere, and then the conversion factor in this particular case here, it should be placed, it should be rotated, because what we want to do here is we want to come up with the ampere. If you want to come up with the ampere, it should be placed in the numerator here. Okay, since we want the ampere, so 1 ampere is equal to, we have 1,000 milliampere. So The milliampere will be canceled out, cancelled. So will only have the ampere here. So basically, you're just going to divide the 100 by 1000. So you will come up with the same result here, the zero point 0.1 ampere. Okay, so if you have some questions in clarifications, please comment down below and I will see you in the next lecture. Okay, see you.